right, so here's question number 3, again from the 2016 free response practice exam that they give us. And that was from a few years ago. Now, technically, this one's without calculator, but I don't know if a calculator would help us much anyways. It's more conceptual than anything else. So let's read this together. A continuous function g is defined on this closed interval from -8 to 6. The graph of g shown above consists of 3 line segments and a quarter of a circle centered at 0, 2. Let f be the function given by this. So notice that f is given using this graph g, where it's with that. Find all values of x in the interval from -8 to 6 in which f has a critical point. Classify each critical point as the location of a local minimum, maximum, or neither, and then justify your reasons. So a critical point for this, for f, would mean if you take the derivative and it's either equal to 0 or f at x is undefined from -8 to 6. So what are some answers here? What are the critical points here? So first of all, here it's equal to 0, which is at -6. -6. And the other one is at 2. Now, you might think, well, isn't it undefined up here? And the answer is the derivative is undefined here because it's a cusp. But the actual function is not undefined anywhere. It's continuous all the way through. So there's nothing here that's undefined. There's no holes or breaks or anything. It's continuous all the way through. So where are the two x values where it's equal to 0 looking off a graph? So when x equals -6 and when x equals +2. Recognize that when you go from negative to positive, and you might want to have a number line from -8 to 6, and understand from -8 to -6, it's negative, then -6 to +2 is above and then below. This might help you understand that at -6 is a minimum and at +2 is a maximum. So did I just do that wrong? Let's try it again. Negative to positive. Yes, negative to positive. That's a minimum. Positive to negative, right? Did I draw minimum? But then I said the word maximum. Get my head in the game here. Minimum. Why is it a minimum? Because it changes from decreasing to increasing. They love those words, decreasing and increasing. Make sure you include them in sentences. From decreasing to increasing. How about the other one? At x equals 2, f at x has a minimum value, or maximum value now. Why? Changes from increasing to decreasing at x equals 2. So they love those words, increasing and decreasing. Just doing a line and showing plus or minus is not enough for them. They love the words increasing and decreasing. You understand what a maximum and what a minimum means. All right, part B. It says, can you find, and I'm going to do this. I'm going to fold it, and I'm just going to have the graph in front of me as I answer it. Is that okay? So the next question is, can you find f at 0? Well, f is defined by, so we first of all have f at x defined as -8 to 0, g at t dt. So if I want to find, negative 8 to x, then I'm going to write down f at 0. So wherever there's an x, put in 0. And that's what I'm looking for off the graph. So if I'm looking off a graph, how do I integrate off a graph? Is I find the area underneath. So from negative 8 to 0, can you find its area? So let's look. So focus it in here. All right, so above and below. So from negative 8 to 0, first of all, there's a triangle here, so I'm going to do that. So how do you find the area of a triangle? And it's going to be a negative one, but it'll be fine. So the base is 2, and the height of it is negative 2. So it's really 2 times negative 2. So if you just use the y value, it'll automatically make that a negative area anyways. So the base is 2 and the height is negative 2, which gives us a negative answer for that. Then we have another triangle here. Oh, guess what happens to these two triangles? They're exactly the same size, right? So they cancel out. It would be nice to just even see that to begin with. Keep going. We have a rectangle right here. Do you see that rectangle? So I'm going to keep going. So notice the above and below, they cross out in terms of positive and negative. But I have a rectangle here, and it's 4 by 2. And so 4 times 2. So the rectangle is 4 times 2, or 8. And then I have a quarter of a circle. So all I need to know for that is it's pi r squared, so I just need to know 1/4 of that. What's the radius of it? And again, the radius is, it's centered at 0, 2. So the radius is 4. And that's it. Now, you could write it better, maybe, but it's not better. 16 divided by 4 is 4, 5, but that's a great answer right there. Part C. A limit question. Now, ultimately, a limit is a substitution question. So what's the limit as x approaches negative 4 of this? So if I understand this correctly, I'm going to, first of all, I'm going to separate the top and bottom because I kind of know what's going to happen here. So the top, what's the limit as x approaches negative 4 here? So from negative 8 to negative 4, what is the area from negative 8? Well, negative 8 to negative 4, we kind of did this already. The above matches below, they cross out, so that answer is 0. And when I look at the denominator and I plug in negative 4, guess what? That answer is also 0. That's 16, take away 16. This is indeterminate, which means, back up here, I'm going to take the derivative. So if I take the derivative of f at x and recognize that f at x is an integration, when you take the derivative, they undo each other. This is called the fundamental theorem of calculus. They cross out. And then what do you plug in instead of x, t, you plug in x. So this is just going to be g at x. Done. And then the denominator will be 2x plus 4 when you take the derivative. Again, we're going to plug in negative 4. So if I look off my graph, what's the value at negative 4? So at negative 4, what's the x, y value right there? So at negative 4, the answer is 2. And then when I plug negative 4 in here, you get negative 8 plus 4, which is negative 4. And that's it. You could also write down negative 1/2. All right, last question. Let h be the function defined by this. Can you find the derivative? So if I want to do the derivative, first of all, recognize how it's defined by. What rule would I have to use here first? And because I'm dividing, I'm going to use the quotient rule. And the question is, what is the quotient rule? It's the bottom times the derivative of the top minus the top times the derivative of the bottom, and then the bottom squared. And then once you have that, then you're going to plug 1 in everywhere where there's an x. Now, some things you don't have to simplify, and some things you do. So this right here, the derivative at 1, you need to find it. So at 1, what's the derivative of g? So at 1, what's the slope of this line? So this point up here is 0 and 8. Right? Because so 0 and 6. Yeah, 0 and 6. This point down here is 3 and negative 3. The derivative at 1 would be the slope there. So I'm just going to do it right here even. What's the slope there? That's negative 3 subtract 6, and 3 subtract 0. It's a negative answer. So the slope of that line is negative 3. So I have 1 squared plus 1, that's 2. The derivative at 1, we just said, is negative 3. What's the value of g at 1? So not the derivative, just the y value at 1. So here, don't assume what that is. You need an equation of a line to find what the y value is there. So I already know the slope. I know a point. I'm going to use it. And then what number would I plug in is 1 to find what it is. So it's negative 3 plus 6. So that's positive 3. But don't assume it kind of looks like what that is right there. You do an equation of a line and then plug in. So it's 3. 2 times 1 is 2. And then 1 squared plus 1, that's 2 squared. And you can leave the answer like that. Of course, you could finish it. Negative 6 and negative 6 is negative 12 divided by 4. So the whole answer is negative 3. All right, great job doing your work. This is Mr. G Math, over and out.